Welcome everybody to the InfoQ podcast. Today is a special episode where I discuss the trends I see in robotics with Ben Dart. However, to discover what the trends are in robotics, we decided to visit ICRA, the International Conference on Robotics and Automation. ICRA is an academic general robotics conference, which attracts over 4,000 people who are working in both research and the industry. The conference is very large and has both an academic part, where researchers are publishing and discussing their research, as well as a more commercial part, where robotics companies try to sell everything from complete robotic solutions, robotic parts, and special software. Or maybe they are just trying to recruit the best of the robotics engineers who are walking around on this conference. As I already mentioned, I visited the conference together with Ben Dart. He is the team lead of robotic perception at the company Emercent in Brisbane. He has a lot of work experience in writing software for everything from mining apparatus to self-driving cars, and is now working on autonomous drones and walking robots. He is always working on the cutting edge of software for robots, and due to his wide range of experience, he has a good view on what the state of the field is and where the field of robotics is going. So without further ado, let's listen to what his impressions of the conference were. Ben, welcome to the InfoQ podcast.
Thank you, Roland.
We just went to ICRA a couple of days, the International Conference for Robotics and Automation. What were your overall impressions?
So I have not been to a conference of this scale before. So the impressions were, holy moly, there's a lot of very cool robots that I didn't know about. We spent somewhere in the region of 5 hours just walking around trying different robots for a variety of different purposes, and they were all so unbelievably cool, with a huge amount of unbelievably passionate people driving these booths, and largely engineers that just wanted to talk to other engineers rather than it wasn't a sales event, which was also really very cool.
It was definitely a really cool experience of us trying all the robots together. I think one of the things we tried a lot, and which was definitely new compared to, the amount of companies working on telepresence robots this year was far higher than last year. Which ones did you like the best, or which ones did we try?
We tried a couple of different ones. So the Richie robot by Poland, the robot, a very cool concept, so doesn't need to walk or do anything like that, has a mobile base using omnidirectional wheels, and then arms built simply from a series of servo motors. The woman said basically it's super cool because their purpose is to deliver it as a research engine. And so when I was talking to the woman, she was like, yeah, so for that nature, you can buy it from us, which is the simplest way to do it, and we provide it for a very reasonable price, but the whole thing is also just open source. So the mechanical design, the software, everything for that robot was open source.
Oh, so you can build your own telepresence robot at home?
Yeah, you can, which is crazy. What a cool idea. That's quite enabling. And then it worked quite well. So you used a VR headset. The remotes would track your hands, and then you would basically manipulate the arms using that, and then you could close and open the grippers using a button. And that was just so much fun. I don't know where you would use it for outside of research purposes or for fun, but the concept is quite cool.
So we also tried Shadow Robot, which was basically 2 hands, which you would control individually through your fingers, right? What did you think of that?
Yeah, it was a super cool concept. So the motion capture system that they use was excellent. So it really, the fidelity with how when you moved your hands and you moved your fingers, it tracked really, really well. And when I was talking to the guy, I'm like, so how good is it? Can you pinch things and pick things up and do things as if they're your real hands? And he said, yeah, so at the moment in the state that we used it, which was already incredibly impressive, it was fully uncalibrated. He said that there's significant effort to make sure that it matches the size of your hands so that when you do movements, they track really closely to your hands. And that wasn't done because it would be a huge waste of time to do that for a demo at a conference. But even without that, you could pinch things and pick them up and move them around.
Yeah, we could take these very tiny cubes and just build a whole tower out of them. Yeah. And I think you even managed to grasp 3 cubes at once with 2 fingers.
Thank you. Yes, I did achieve this, which is very impressive. So it was quite intuitive. I mean, you think about this sort of thing and how long would it take you to learn how to use a robot hand to pick up some stuff? But like, I don't know, we were doing all of this 60 seconds after we started playing with it.
Yeah, I think that's one of the more impressive things is that we managed to, in the past, whenever you want to try to use a robot remotely, someone would always have to tell you, these are the buttons, these are the locations, etc., etc. And we're now just strapped into some set and immediately understood how to use it, which is a big leap from how it was in the past. You also said something about the collaborative nature of these robots, so we could just walk around them, which might sound very unimpressive to people who are not into robotics.
Well, yeah, so I mean, I used to work for an industrial robotics company, and like that was 6 or 7 years ago. And at that time, like fully collaborative robots were like very few and far between and not particularly well thought out. So at that time, if you walked into a room and saw people just swarming around these robot arms, so like we're talking about the shadow robot with the hands were connected to Universal Robotics 6 Degree of Freedom industrial robot arms. And there was a time where it's inconceivable that you would just be walking around and like interacting with these robots without safety cages and cutoff switches and all this sort of stuff. And now like almost every stand, well not almost every, like a huge percentage of the stands had just running collaborative robots, which is super cool.
Yeah, there were so many robots just walking also through the audience. I think we saw one incident where a robot just somehow didn't respond anymore to things and just kept walking.
Yeah, cleaned up a catering stand.
Yes.
Just, took it with it. It was hungry robot.
Yeah, but it was also a very tiny robot, so it couldn't really do a lot of damage. But besides that, the larger robots, they're all just roaming freely through the audience.
Yeah, a couple of wheeled robotics as well. I mean, we played with a balancing wheeled robotic that can shift and balance its weight. And yeah, that was also extremely cool. Yeah,
and also there, we asked them, can we try it? Can you hand us the controller? And they just immediately gave it to us. And we didn't get a whole safety briefing. They just told us this is forward, this is backwards.
Yeah, takes a little bit of trust, but I think that you've got a lot of people that are enthusiastic but serious about.
But does that mean that we will see these robots now more often on the work floor? Do you think your colleagues will start using telepresence robots all day, or?
I think there's a long way to go before we get to that. So I talked to each of these prospective telepresence robotics companies, and the business case was commonly for giving to research organizations rather than for companies to use for specific teleoperation purposes. So it was quite interesting because, I mean, at least for me, I didn't realize there was such a huge market for research organizations, but there is like the people are doing some crazy things with these robots. I think when I was talking with the Shadow Robotics guy about this, he was basically talking about a large quantity of his customers. They provide an API endpoint, want to try and integrate some ML into this, some sort of like AI process to do something. We didn't elaborate that on too much, but I think that that's going to be interesting with like whether or not they go deeper into this with, you know, having these machines rather than being telepresence controlled, being controlled to do some repetitive tasks or something like that.
Yeah. And even for the telepresence, I can imagine that it will be a thing where for some simple jobs, or if you want to talk to a coworker at work, it will be easier to just drive some robots to them instead of sending them a Slack message. So you can immediately physically poke them.
Yeah, now you can tap them on the shoulder. Or accidentally crush their collarbone.
That could happen depending on which robot you're using. Yeah, I think then the smaller robots we tried are definitely better than the massive robot arms we tried. I think actually last year at ICRA, a friend of me couldn't attend, so she logged into a telepresence robot and then drove like behind me, so she could also talk to the people at the conference floor. And at some point I logged into a different telepresence robot, so we could talk to each other over two different telepresence robots. Huh. That was quite a good moment.
What an interesting concept.
Yeah.
We didn't see too many of the traditional, because there are several companies doing traditional telepresence where it's just a robot with a screen on wheels that you can pilot from a web browser or something.
Yeah, but I have the feeling that she didn't get a lot of replies from people. It took a bit of convincing for people to try to talk to an iPad. I have the feeling that as soon as you have hands, that will change a lot, because then you're really feeling like a physical presence for other people as well.
The X Prize winner was, I guess, a telepresence robot that you sit in a chair and you control the hands. And from looking at the stand and watching the person operating it, it appears that you use your feet to turn a wheel, and then you have a pedal or something like that, and that allows you to drive the robot and rotate it. And then you have arms that copy your motion, and you have a VR headset, and the robot has a camera and a head that moves around and a screen with your face on it. And yeah, like that would give you quite a high ability to move around inside an environment and interact with that environment that I guess companies like AnyBots and Beam and some of these other ones that produce the screen maybe will want to like adopt something along those lines.
Yeah, I can imagine. Anyways, your line of work is more working on drones. What did you think of the presence of drones?
Yeah, so the drones that we saw, I think we only saw one major drone stand, and it was super duper cool for like a variety of reasons. And I think it was a bit of a shame at this conference that they don't help to provide an area where they can do drone exhibits. So from talking to the one drone company that was there, they were talking about how it was like quite an effort to get even their tiny little, essentially harmless drones to operate inside the arena. And they had a net and everything, so it's perfectly safe. But I mean, a net, like there's extremely safe drone nets and you can have tethered drones and all that sort of stuff. So there could be a place there where they have more drone exhibits because they're both super cool and like it's a large part of the sector. But the one that we did talk to, they had like two things that I think were unbelievably cool. So they had the Flappy Drone.
Yeah, maybe quickly explain what a Flappy Drone is.
Yeah. So like traditionally, all of these little drones are often quad rotors or multi-rotor vertical motion drones. This guy was essentially an ornithopter, like it had wings that it flapped back and forth. And
yeah, so it flies like an insect.
It's like an insect, yeah. Again, like a bigger drone arena would have, like, because when I saw it in motion, it was flying with the wings facing down and it's able to create thrust vertically so it can take off and land. What I didn't know until I talked to some of the people afterwards was that it can actually transition to horizontal flight and fly extremely fast horizontally, which would have been an awesome thing to see. That would have been quite cool. So we'll have to look up some videos about that after. The company is called
BitCraze.
So the company that I work on does drones, but they're much bigger. So usually like a 50 centimeter diameter or bigger. And we carry a payload that does high density mapping of environments. And we have a considerable amount of processing power. Like I don't necessarily think it's a lot. You and I have both worked in self-driving, and in that industry, you have an insane amount of processing power available to you because you can put a lot of computers in the back of a car. On a drone, it's really, really hard because you have to lift everything that you use, and if you have a big graphics card, it draws power and it's heavy. So you're in a super constrained environment. So we thought we were constrained. We're doing some pretty big algorithms, doing a lot of path planning through unknown environments, high quality SLAM to make these maps, all of this sort of stuff. But then when we saw this drone company, these guys have like an 8-bit microprocessor that they're doing machine learning on. There's like a couple of papers that we saw of students that are doing inference engines to find other drones and do like optical flow, but on a computer that it's like almost an Arduino, like it's so small.
Yeah, the students would then distill their neural networks and quantize their neural networks because their processor couldn't do floating point operations, and they can still get a lot of cool features onto a tiny drone like this.
Yeah, which is really cool. And like for me personally, a little inspirational because we don't tend to do so much ML because we don't have access to big graphics. Like graphics cards make running inference engines a lot faster, and we don't have access.
Yeah, normally people use technology, or this is built on technology such as CUDA or Tensor RT, which are fast ways to do inference of large neural networks. And these people manage to get similar performances with very small neural networks.
Yeah, which is super encouraging for us specifically because we don't have access to a massive graphics card. We have a little one and we've got a pretty good processor. But if they can do this sort of stuff on that tiny little computer, then like we can hopefully do some pretty cool stuff on ours as well.
I also think that even if you're not working in robotics, you can still use the same technology to really reduce the amount of servers you need in your server rack as a normal software company. So yeah, this technology is definitely, it's very inspiring to see this.
And then if you are doing that sort of thing, like AWS is money, right? Like every time you run something on AWS, it's money. So if you reduce it, you can essentially save a bunch of money as well, which would be quite an interesting path for this to take.
So what did you think of the Lex robots we saw? So I think most people know the Spot by Boston Dynamics, but on this conference, there's a lot more companies displaying their legged and balancing robots.
Yeah, so apart from the one that destroyed the catering sign, they all look quite good. So this is, I guess, of interest to me because we also do some stuff with Spot, and it is a really good platform, but it is quite expensive. Like it's not a cheap platform. So a good question is like, will there come up applications that the Spot is good for, but you maybe don't need something as robust and as technologically advanced as the Spot to achieve? And then maybe it's something that's more achievable for companies that are smaller and can't afford to invest in robots like the Spot. We also saw some that are like combination of quadrupeds with wheels, which I think is really cool. I really think the quadrupeds are super cool because the problem of foot placement, how to walk around, is like a crazy hard problem to solve. And Boston Dynamics have done an amazing job. But wheels are awesome. Like, we have invented a mode of transport that is like crazy good compared to walking around. And so like you see these quadrupeds that are both quadrupeds, but then they have wheels. And like that would be an awesome combo, because I'd love to see you can transport around on your wheels in most situations. And then if you need to change elevation using stairs or like go up a slope or something, then can you like retract the wheels and walk, or just walk on top of the wheels? Like that's, yeah, some of these like kind of combo robots are quite cool.
We asked Boston Dynamics and they told us that they had about 1,000 or over 1,000, maybe 1,500 or something, robots in the real world. Do you think the adoption will be way higher once they get wheels? Or what do you think is hindering the adoption of this by everyone? Is it now mostly robotics enthusiasts using this? Is there some early adopters?
Yeah, I think it's mostly research organizations. Like maybe I can talk about our personal use case and then talk about some of the like the stuff that we talk to people about. But like we use Spot because we're interested in doing environments that are like highly uncontrolled. So an example would be underground mining. The Spot represents the ability to walk around on ground that you don't necessarily know about. There's like uneven surfaces or rocks or stuff like that, which a wheeled robot won't do. So in our case, something like a wheeled one would only be useful for transiting to and from the areas that you can only pass with your legged form. I think hurting the adoption is, I would say there's two reasons. Like there's the price point and there's like the use case. Like what exactly is this useful for? So it seems like what's coming out of this is that the Spot is incredibly useful for routine inspections and that sort of stuff. So like there's examples of Spot being used in hydro plants, in dams or in nuclear facilities, where you basically have a Spot that's docked, it has a camera on the top, you program into it because it has like the API gives you a native API for waypoint following and this sort of stuff. So you basically walk it around your factory and you take pictures of specifically interesting things. A valve that has to be off all the time, or like something that you've noticed in a previous inspection you want to check again. And this is a really cool concept for the Spot because you can sort of just deploy this one robot inside a much larger area. It can walk upstairs, it can move around and do lots of stuff. But if it's a routine inspection, you can solve the same problem by just having cameras everywhere. And putting 500 cameras in is still cheaper than buying one Spot and potentially simpler. So I think it's that. It's quite difficult to come up with a use case where that like very expensive robot is better than some of the solutions that you have, especially in controlled environments where you can change everything about it.
Yeah, that's also what they told to us, that the biggest competitor is people just directly changing the environment, just directly placing a camera.
So that's why like the search and rescue stuff, like going into uncontrolled environments like caves or in forest areas or stuff like that, is like very interesting because like controlling a forest is a bad idea. So you sort of just have to find the right reason to use it, and then I think it'll be a super successful type of robot.
Nice. Maybe talking about AI and machine learning algorithms, did we see any companies who were selling anything specifically? What did we see people do with software and emerging technologies such as this?
Yeah, I guess I was mostly focused on some of the hardware aspects because there's a lot of people selling platforms, but there weren't too many people selling like direct software algorithms. We did talk to the people doing the software calibrations.
Yeah. I think the calibration is indeed very important. That one thing which is different from maybe the normal software industry is that in the normal software industry it is still hard to do a perfect data set, but at least your sensors are always good. In robotics, you also have to make sure that your sensors align to each other, and that seems to be a difficult thing. What I did notice is that the robotics still has a really interesting mix between people using deep learning methods and people using traditional algorithms, which just work a bit faster on the low processing power they have.
Yeah. I guess in terms of companies, we feel like we didn't see many, but there were plenty of students that were struggling with this. So we talked with a couple of different of the poster presentations that were doing machine learning algorithms and had some really cool concepts of things to do with them. And then, I guess the one that stuck out for me was there was a poster about finding emergency landing sites, which is relevant to me. I work in the drones. The drones go into places where you can get into a region where you have critical battery or some error and you need to land, but you don't know where to land. And at the moment, the approach for most drone companies, like us, DJI, everyone, is just fly down. But if you're above a tree, like a canopy, then you're going to fly down into trees, which is, bad for your drone.
I know that feeling.
Yeah, there's plenty of papers that are dealing with these sorts of things, with using LiDAR data to calculate areas that are safe to land, and the one that we talked to specifically was doing it with a traditional approach, finding and estimating normals and trying to calculate ground planes. But yeah, I can see that there's slowly plenty of people that will be working on similar things using ML approaches as well, because it can give you very high performance and also be quite fast. Some of the traditional methods are quite hard, computationally. So in these drone platforms, you don't have an RTX 3080, some crazy graphics card just sitting on there. So you need to be able to do it fast and with a small amount of hardware.
So how about self-driving cars? One thing I noticed in the last years I went to this conference was that there were a lot of self-driving cars companies advertising, from Waymo to Tesla to Argo. How was it this year?
Yeah, so I think we only saw Waymo and Wave. As with the industry itself, feels like it's dropping off a little bit. The Wave one was quite good. When we talked to the people at Wave, they had quite an interesting demo about you could drive inside of their simulator, which was cool. And they had basically used a nerf to generate three-dimensional visualizations from real drives using just a camera.
Yeah, so they drove through a part of London with their real car and then trained a neural network to create this neural radiance field to regenerate the environment around you. So you could drive through the regeneration of the learned environment.
Yeah, which is quite a cool concept. And then talking with them, it was super cool because there was a bunch of them there and they were super keen to answer questions. And we got into technical discussions about how they're trying to solve some of the safety issues and stuff. And they were really upfront with this is work in progress. And they weren't trying to spruik up or lie about anything or try and cover up that this is an insanely hard problem and there's going to be challenges, which was good. I guess we didn't visit the Waymo stand, it's there, but they didn't have a demo of any sort, so...
They also had a very small stand. Their stand was very small compared to previous years, I feel.
Yeah, right. So I guess maybe they're at capacity, don't have any hiring in the pipeline or something like that.
Yeah, I don't know. I don't know if the reduction in self-driving car companies here is due to money or because the problem is harder than expected or because they solved the problem. We don't know.
If they solve the problem, I feel like that will be an exciting ICRA 2024.
Yes.
Everyone gets there in self-driving cars. I don't know, from what I understand, it's still an incredibly hard problem, even with the constrained operational environments that people are trying to operate in. So it's a space that we've both moved out of, but I'm very excited about it still. I just hope that more cool things happen rather than the whole industry collapsing.
Yeah, no, indeed. I hope the same. It also looks like there's still progress. We still saw a lot of students working on the same problems. So there still is progress in being better at detecting what's happening in the world around you. Maybe then going to a more easier or a more directly applicable problem, agricultural robots.
Yeah, so I think agricultural robots is something that's growing really quickly. So I've talked to some people at a company called Swarm Farm. They were not present at the conference, but I've talked to them separately. And agricultural robotics is an incredibly interesting problem. So at the moment, you have a lot of people from big companies working on it. So John Deere and this sort of stuff. And they present a lot of really, really cool technology to do with farming, but using people-driven tractors and all that sort of stuff, but using technology, enhancing that. Potentially they have an agricultural robotics program, I'm not sure, but they were the only people present at the conference and they didn't seem to have information about that. But it's an incredibly cool robotics problem. It's a semi-constrained environment, so you have some of the difficulties of stuff like self-driving cars where you have to navigate in terrain where there might be obstacles, or the traversability of things is really hard. It's a farm, right? So mow every day. So sometimes you get really long patches of very long grass and it's can I drive through that or not is a very, very hard problem to solve. And then on top of that, some of these robotics companies are working on solutions that should hopefully be extremely environmentally friendly. So an example that I talked to with Swarm Farm is that they're basically working on or have worked on a system where, so currently how they weed or do pest control and weed a crop is either fly over the top and dump pesticides and weed killer, or they will drive through the middle with these big booms that come off the side of a tractor and spray everything. There's a lot of companies now working on, can we detect weeds and then spray them individually or even kill them with a laser? There's a company that has managed to kill weeds just using laser, which is incredible. That means 0 pesticides. And if you can't use the laser and you can just spray an individual weed, you might save hundreds of tons of pesticides. And that's all stuff that's not then going into the topsoil and ruining it. As far as I can tell, a lot of agricultural robots are aiming for small modular robots. So instead of these massive tractors that just tear up the ground and cause a lot of damage, you have these like little robots that just sort of can navigate through the crop, doing minimal damage, not turning over the topsoil, super accurate. And, this is something that when I've talked to people, like, there's always the concern, will this replace people's jobs? But the farmer sits in the tractor all day and does this, and then has to go home and do all of the rest of his work or her work. So the concept, I hope, is like quite adoptable and will be more environmentally friendly and save us a lot of pesticide use and all this sort of stuff. There wasn't that much representation of this stuff at ICRA, as far as I can tell, so it would be cool to see some of that next year.
Yeah, what I did see on one screen, but I don't think we really talked to these people, was a company which also tried to monitor the individual health of the plants. So if you have a crop, you could drive over your fields, then map every plant you have, and then also monitor that. So you could also identify some areas where you want to have a bit more water, so that these plants also grow faster.
Yeah, you can find diseased ones and then sort of get rid of that part of the crop before it spreads out.
Yeah, so you can very well see in your massive fields where do you have which problems. So that also seems to be an up and coming field where I don't know how far we are from commercialization and this being used every day.
Yeah. I think that several companies have like pilot programs with farms, at least in Australia. So companies like John Deere own a crazy amount of the stake in farming equipment. I think it's like 70% are owned by 3 companies or something of the market share in the world. Don't quote me on that statistic, but it's a big number. So yeah, like there's a lot of competition that can come out of these little robots, and if they're effective, it'll be a really cool space to be in.
Yeah, indeed. So ICRA is more a research conference, which also attracts a lot of companies. How far away are we from commercializing this? Where are we on the chasm? Where are we on the bell curve? Is this purely robotic enthusiasts? Is this early adopters? What technologies we saw do you think are most ready for being used by everyone?
There's a couple of like straight up companies that are there, like Dyson and John Deere and stuff, that just sell a product, and maybe they're there for recruitment purposes or something. And so that's quite interesting. But a very large portion of the other bits, I would say, are very low on the bell curve, like some of these teleoperation robots and some of the drone robotics companies and a variety of others. When you talk to them and you're like, who do you sell these to? I mean, even Boston Dynamics, a large portion of their robots get sold to the research organizations, which I guess are like at the bottom end of the bell curve, right? Like they're absolutely on the like trying to develop these technologies into something. I mean, I couldn't put a time on it, but like, I don't know how long it takes usually if you come up with a really good idea, and it's a hardware startup, so it always takes longer. But, something like these hands, we're starting to see, maybe there was like 4 or 5 companies that are producing robotic hands for researchers. So they're selling to researchers. At some point, I guess someone in a research program will come up with an incredibly good idea. They'll spin that out, and then that will become popular. But that's got to be many, many years away. So I'd say, early on the...
Was there anything where you thought, this can totally be something which we can all buy in the next 5 years?
Something that we can all buy. I mean, as a company, we could potentially buy some. I mean, like a lot of the legged robots, companies are starting to investigate what they can do with it. Certainly, like if you're a hydro dam owner or something, like there's going to be applications that bots and legged robots are used for in, I think, the near future. Certainly there's a lot of companies investing a lot of money into trying to find the right use case to be able to sell lots of those.
Yeah, the legged robots are definitely, we see them improve every year. It's amazing to see how fast that goes. And the amount of spin-offs and competition which is starting is also incredible to see.
Yeah. I mean, they're actually also now just running student competitions, right? Where like we saw there's like an obstacle course for legged robots where I guess you path plane through it.
Yeah, I think the National Institute for Standard and Technology has set this up. So they are now trying to figure out, can we find a good metric for how useful these robots are for search and rescue? So they set up a whole competition where a lot of universities can compete with their legged robots to see how useful it is. But the fact that people are thinking about standardizing this technology helps a lot, I feel, for the adoption. Okay, so then maybe the last thing, if I want to work with robots or if I want to get started with something, what are the entry-level robots? What should I play with? What should I buy? What should I try to use in my work?
Yeah. So We went and saw several dev kit robots. So there was a company, Viarm, I hope I'm saying that right, which develops a platform sort of like a more sleek version of the Turtlebot, but they provide a really cool API for controlling the robot over a web interface and this sort of stuff. There's plenty of the drone ones that produce the little hobby drones. It's hard to say, like as a robot hobbyist, some of these were out of reach for me personally. Like unless I had a really good idea for something that I would go and do, I wouldn't go and pay the $400 or $500 sort of Australian dollar, convert that in your own terms, for a robot just to mess around with at home. I would want to have some good idea, but certainly for like companies investigating interesting solutions, like it's quite a good little platform there. But I mean, yeah, like plenty of people do invest in that. Like I talked with one of the people about, there's a platform called Telio, which makes like drones that you can program with a Scratch-like language to fly around. And this sort of thing, I think is like a super cool idea, because there's plenty of robots like this as well for like driving robots. So you can teach like younger people about robotics and teach them that, like how to make logic and make code in the simplest format to do really cool things. I think maybe Parrot does something similar, but like that sort of thing, we did see that around a little bit as well, and that would be super cool.
Yeah, I absolutely agree with you on the price point for entering this technology, that if you want to learn programming, you can do it using any laptop, just starting with JavaScript. If you want to play around with robots, it will easily set you back multiple hundreds of euros before you can do anything very interesting.
I guess it's a steep entry point. So yeah, it's hard, right? Because it's hardware. You have to buy something. There's plenty of stuff that people do in simulation. Like you can easily get something like Gazebo going and do robotics inside simulation, but it's not
what makes the field exciting.
Exactly. When it's driving around your house or flying into your walls or whatever like that, that's when you've got the excitement. So
yeah. I also think the one thing you mentioned before, the Turtlebots, they are kind of beginner robots. Mm-hmm. So the Turtlebots are often one of the first programs you write where you can just tell a robot, go forward, go backward, read what is happening with your sensor data, and based on that make a decision, right? So you have this whole perceive and act loop. I think those are the closest things we have in robotics to a standardized learning platform. But for computers, people can nowadays just buy a Chromebook or buy an iPad and get started with that. So you have a standardized platform. Would there be a need for something like this in robotics?
Do you mean for software or for the hardware platform?
Both.
I think ROS makes up the software platform. If you're going to do robot, like I don't think I've ever met anyone that in this field that hasn't heard of ROS. So like if you Google write a robotic program, you'll end up at ROS, and they provide pretty good tutorials for how to do a lot of like simple things. And they provide a huge tool set to be able to do all that. So that feels like if you're starting off in the software world, you'll end up going through there at some point. For the hardware, like it's really hard because there's so many different types of robots. Like you can have your diff drive wheel robots or your omnidirectional ones, and then arms or drones or cars. So
yeah, indeed. For ROS, it always is very easy to get started with something. But in my experience, if you have your own kind of cheaper custom hardware, that's also when you have to start your own modules in ROS, which is a bit of a shame.
Yeah, I mean, like ROS provides a huge number of drivers for some of these. And a lot of the companies that sell introductory robots provide, I'm guessing, a ROS API. It's a clever way to do it. But yeah, you're right. As soon as you if you go to eBay and buy some extremely cheap robot arm that's made of servos, then you're going to have to write your own CAN bus interface to it, which is a stepping stone, right? Like it is hard to find that combination of really cheap hardware that you can easily start with without spending $600 as someone that's never played with one before, as well as getting the easy to introduce software. I would say as well, like it depends on your level, right? Like you always need to start somewhere, but if you start with just trying to develop ROS nodes, like you have to program in usually Python or C++, or learn how to interface to ROS through one of the packages that provides the API to other languages like Rust or whatever. As far as I don't know if there's like a Scratch interface that allows you to write a ROS node. So there's also the whole, you have to learn how to program a little bit before you can start using ROS, which I guess is a little barrier.
Yeah, I think in the past we also had the Lego NXT robots. Those were really amazing, but I think that Lego killed this project a couple of years ago.
Oh, really?
Yeah.
The Mindstorm?
Yeah, the Mindstorm.
No way. That was so cool. We even used that at university. Like,
yeah,
it's such a good concept because you can just build a robot arm and then control it and then break it down by the end of the lesson.
Yeah, those things were really amazing and also had a relatively good price point, but I think they're not there anymore. But I could be wrong. Yeah, I think they stopped the division, which is a shame.
The other, if you want to talk about the Hello Robot one as well, like the other cool thing about that was just simplicity. So like some of the robots that we saw with the big arms and 6 degree of freedom robots and stuff are like complex and hard to get into, but like there was at least one demonstration from a robot that's like the simplest format of robot you can have. A diff drive base, 2 linear actuators, a couple of servos. It's like robust, provides a really easy API, and I think they have like a right to repair sort of dealio as well. So like they don't stuff you around. If it breaks, you just fix it yourself.
Yeah, so basically their robot was a stick which could go up and down and left and right. Yeah. And what more do you need to grab a cup? That's literally everything you want. It has a very tiny arm which can open and close. So you just, you could go anywhere and reach any height. And it was all very simple. It was perfect.
Yeah, and it's, so if they, when I talked to the guy, I think, well, maybe they had it advertised. They have a ROS API for that, I believe. So
yeah, I think so.
Pretty easy to get into.
Yep. All right. Yeah, then thank you, Ben, for visiting ICRA with me. And thank you for joining the InfoQ podcast.
No worries. Thanks, Roland.
So that was the interview with Ben Dart. I hope you enjoyed this special episode, and I hope you have a better view on what the trends in robotics are. The field of robotics is still small, but very much emerging when looking at what is happening at conferences like this. I would like to create more content for InfoQ around the field of robotics, so please tell me whether you liked or disliked this episode and what you want to know more of. That said, thank you very much for listening, and thanks again to Ben for joining.